Have you ever wondered how a star dies? Or better yet, what happens while it's dying? Almost always the answer is a supernova. Star classification is pretty complex stuff. There are tons of different kinds of stars. Blue giants, white dwarfs, red giants, red supergiants. For example, our Sun is considered to be a type G2V yellow dwarf main sequence star. Yeah, don't even worry about what that means. Plus, each type of star has a different size, brightness, temperature, and lots of other things. Pretty much all stars are unbelievably large. Even our own Sun could fit 1 million planet Earths inside of it, and it's considered to be an average or even small star as far as the rest of the universe is concerned. This giant size causes tremendous gravity that's constantly trying to come crashing in on the star, and this pushes everything that the star is made of down towards the core. The pressure and density inside of a star would be truly unimaginable, like being millions of miles deep in the ocean times a million. Even microscopic atoms, the very building blocks of our universe, can't stand this pressure. Warning, we're about to get a little scientific, but it shouldn't be too bad, and if you don't care, take a 20-second power nap. Starting now, hydrogen, the most simple and common atom in the universe, is everywhere, especially inside of stars. The tremendous pressure inside of the star is so strong that it strips hydrogen's electrons, leaving only a bare nucleus. And under this crazy pressure, the bare nucleus of hydrogen combines with other bare nuclei, fusing together, making heavier elements like helium or oxygen. In physics, this is known as nuclear fusion. And now the new heavier elements have tons of extra energy they're not used to, and they're not exactly crazy about this. So they release or emit the energy as radiation. This radiation spills into space, and some of it becomes the very light that heats planet Earth. Not to mention this powerful energy flowing outward prevents A star's gravity is constantly pushing out with nuclear energy and trying to come crashing in with gravity, and this delicate gravity-nuclear balance is how stars stay alive. But eventually, like a car running out of gas, the star runs out of atoms to fuse, and there's nothing to stop gravity. As a result, everything that the star is made of comes crashing into the core. All of this matter, stuffed into a small place, becomes a nuclear time bomb. All of the matter and radiation blasts out into the universe in a catastrophic explosion known as a supernova. Every single element that we know on planet Earth came from exploding stars. The nitrogen in Earth's protective atmosphere, the calcium in your bones, and even the gold in your jewelry. Supernovas occur in two types. Type 1a supernovas happen when one or more small, dense, and hot white dwarf stars gradually collect enough mass, collapsing and setting off a chain reaction nuclear explosion. Type 2 supernovas occur when a supermassive star, 10, 20, or even up to 50 times the mass of our own Sun, collapses, causing massive nuclear explosions. But not every star's life ends in a supernova. Depending on its mass, some stars simply become a planetary nebula. Some extremely massive stars will explode, leaving behind a black hole. Others only a neutron star or a pulsar. There's no predicting which star near planet Earth will explode or be the next to go supernova, or when it might happen for that matter. But if a supernova did occur close enough to Earth, it would be so bright it would outshine everything but the moon in our night sky. It would even be visible during the daytime for several days or weeks even. Throughout history, the writings of ancient civilizations from all over the world told of suddenly appearing guest stars in the sky, some of which were even visible during the day. It would later be determined these were, in fact, supernovas. Fortunately, astronomers are confident that no supernova in the near future should occur close enough to Earth to cause any serious harm. But as always with our universe, we can never know for sure. For more articles and videos about supernovas and a top 10 list about the next 10 stars most likely to go supernova in the Milky Way,